Hello guys, magandang gabi. So ang topic natin for this week is about annuity. But for this session, we are going to discuss how we can compute ordinary annuity. So by definition guys, ang annuity, they are essentially insurance contracts. You pay the annuity. So it is an amount set for today or over time in exchange for a lump sum payment or stream of income in the future. So virtually they are investments or insurance po. But we can we can simply define an annuity as a series of payments made at equal intervals. For example, you bought you bought a motorcycle on installment basis. You're paying 3,000 monthly, so that is a series of payments. Monthly, you're going to pay 3,000, so equal intervals, meaning every month. How about Lumipad House? You purchase it on installment basis also, paying 12,000, for example, every quarter of the year. So again, you're paying a series of payments, which is 12,000, equal intervals every quarter of the year. Now, for our SSS or GSIS, those are also called or considered as annuities because we pay monthly for those insurances so that we can have a lump sum or insurance at the future. Another example, John Mark pays 5,000 monthly for 10 years for his college education plan. So that is an annuity. Jim Bird is paying 2,500 per month for 3 years for his motorcycle loan. So those are examples of annuities. Now there are two types of annuity. First is the simple annuity. So let us compare it side by side with general annuity, the other type of annuity. So a simple annuity is where payment interval is the same with the interest conversion period. For example, John Mark pays 5,000 monthly. So take note of the word monthly. So he is paying 5,000 monthly in an account which earns 3% interest rate compounded also monthly. So if you can see, the frequency of payment and the frequency of conversion is the same. So that is called a simple annuity. Now, the general annuity is where payment interval is not the same with the interest conversion period. Example, again with John Mark, he is paying 5,000 monthly. So this is the frequency of payment monthly in an account which earns 3% interest rate compounded yearly. So the frequency of conversion of the interest rate is yearly. So these two are not the same. So this is called a general annuity. Under simple annuity, there are two types of annuities or two types of simple annuities. First is the ordinary annuity and the annuity due. Let us compare them. Ordinary annuity is where payment is made at the end. So this is the keyword at the end of each period. For example, John Mark pays 5,000 pesos at the end of each month. So John Mark is paying monthly, but he chose to pay it at the end of each month. Okay? So this is an ordinary annuity. Now, for the annuity due, this is where payment is made at the beginning of each period. For example, again, John Mark pays 5,000 at the start of each month. So, John Mark is paying 5,000 monthly, but he chose to pay 5,000 at the beginning of each month, making this case an annuity due. Now, for this session, we're just going to focus on ordinary annuity. So, for example, John Mark pays 5,000 at the end of each year. So again, the keyword is at the end of each year. So making this an ordinary annuity in an account which earns 3% interest rate compounded yearly. As you can see, the frequency of conversion of the interest rate is yearly, while the frequency of payment is also yearly, so making this a simple annuity. Find the value of the annuity after 4 years. So let us identify the given. So the big letter R will stand for our regular payment, which is in this case 5,000 pesos. The small letter R is still our rate, which is 3% compounded yearly. And T is for our time or term, which is always expressed in years. In this case, that is 4 years. Let us try to analyze or to illustrate first how ordinary annuity works. So, in the case of John Mark, he's paying 5,000 at the end of each month, at the end of each year. For example, in year 2021, at the beginning or the start of 2021, John Mark still has no balance because he's still about to pay 5,000 at the end of year 2021. Okay? Now take note that the interest earns always at the end of each period. So meaning at the end of 2021, the amount of money which John Mark has will earn an interest of 0.03 or 3%. So 0 times 0.3, so no interest. Then at the end of each month, at the end of the year, John Mark is going to pay 5,000 pesos. Okay? So again, at the end of this period, John Mark will now have 5,000 pesos at the end of year 2021. Now come 2022, the balance of John Mark is 5,000, which came from this one, 5,000, this one. Now, at the start of 2022, he has 5,000 pesos. Now, at the end of 2022, it will earn 3% interest or 5,000 times 0.03. That will give John Mark 150 pesos interest. Okay? Then he will pay another 5,000 because it is the end of the year. So how much will be the ending balance? So how are we going to add this? So we'll add this 5,000 because it is the balance at the start. Then 150 pesos, the interest earned by 5,000 pesos. Then plus 5,000 pesos. So we will have 10,150 pesos. So this is the amount of money which John Mark has at the end of year 2022. Now, at the start of 2023, John Mark now has 1,150, which is the same amount which he has at the end of 2022. Now, multiply that again by 3% or 0.03. So it will earn an interest of 304 pesos and 50 centavos. Since it is the end of the year, he will pay another 5,000 pesos. So the total amount of money that he will have at the end of 2023 is 1,150 plus 304 plus 5,000. So total of 15,454 pesos and 50 centavos. Now the same goes with the beginning of year 2024. You'll earn 3%. So this is the interest. He will pay another 5,000 pesos. Then add these three values, and you will have the amount of money which John Mark will have at the end of 2024 or after 4 years. So this guy is the future value of the investment or the annuity of John Mark. Now let us try to solve the future value of John Mark using the formula. So this guys will be the formula. So F is equal to R times quantity 1 plus J raised to N minus 1 all over J, where F is the future value, R is the regular payment, J is the interest rate per period which can be computed using I divided by M, or where I is the interest rate and M is the conversion period. Raised to n, exponent n, which refers to the number of payments, which can be computed using the formula T times M, where n is the number of payments, T is for term, number of years, M is the conversion period. Okay, let's go back to John Mark. So John Mark is paying 5,000, okay, yearly, 3% rate, so 0.03 convert to decimal. M is equal to 1. So the conversion period is just 1. Why? Because he is just the interest rate he earned is compounded yearly. Okay? Now let us compute for J. So J is important. So I divided by M, or 0.03, which is your I, divided by 1, which is your M. So divide that using your calculator and you will have 0.03 for your J. Now for the next part, T is 4 years because John Mark is going to pay the amount for 4 years, and we're looking for the future value after 4 years. Again, M is equal to 1. The keyword is the word yearly. The interest rate is compounded yearly. The formula for N is T times M. T is 4 years. M is 1. So 4 times 1 equals 4. So note guys, so these are the three values which are very important to us in solving for the future value. So 5,000, 0.03, and 4. So take note of these values. But of course, before you can compute that, you need these two values for your J, and you need these two for your N, or the number of payments. Well, let's start solving. So first step is to substitute. F is equal to R. R is 5,000 times 1 plus J. J is 0.03, this one. Raised to the exponent N, which is 4 from this one. Minus 1. Minus 1 divided by 0.03, which is your J also. Now using your calculator, let us add 1 plus 0.03, and we will have 1 plus 0.03, we will have 1.03. Okay. Now let us raise this to the exponent of 4, and we should have 1.1255, this one. Then subtract 1.1255 minus 1, and we should be having, yes, 0.1255. The next step is to divide these two numbers, 0.1255 divided by 0.03, and we will have 4.1833 for decimal places again. So multiply these two numbers, finally multiply them, and we should be having the future value of John Mark's money, which will be 20,916 pesos and 50 centavos. Now let us have another example. So Mr. Kufra deposits 2,400 pesos at the end of the month in a rural bank in the city of Balanga, which pays 5% interest compounded monthly. If there were no withdrawals made by Mr. Kufra, how much will be the future value after 5 years? So let us identify what we have here. So 2,400 pesos is your R. That is the regular payment made at the end of each month, meaning this is an ordinary annuity in a rural bank in the city which pays 5% interest. So 5% or 0.05, that's your rate, compounded monthly. So the same monthly here and also monthly payment. So making this a simple annuity. If there were no withdrawals made by Mr. Kupra, how much will be the future value after 5 years? So time is 5 years. Now out of this given, let us identify our J and our N. J is equal to I divided by M. I is 0.05. M is 12. Why 12? Because it says here that the interest is compounded monthly. So in a year, there are 12 months in a year. Then divide 0.05 divided by 12, we will have 0.0042. So this will be our J. Round up to 4 decimal places. Now for time, 5 years. Again, the frequency of conversion is 12. So N is equal to T times M, 5 times 12. So the number of payments is 60. Now using our formula, let us substitute once again. So 2,400, which is your R, 1 plus J is 0.0042 there. Raised to N, the exponent N is 60 from here, is 60 here, minus 1, divided by J, divided by 0.0042, which is also our J. Now, adding 1 plus 0.0042, we will have 1.0042 raised to 60 minus 1. Let us compute that using our calculator. 1.0042 raised to 60, and that should give us about 1.28591. So round up to 4 decimal places, then subtract these two values, minus 1, 1.8 minus 1, and that will give us 0.2859. Then divide by 0.0042, and we should be having 68.0714. Round up to 4 decimal places. And finally, multiply these two numbers. Multiply nyo to, and you will have 163,371 pesos and 36 centavos. So meaning, this 2,400 pesos, if Mr. Kupla will continue paying this for 5 years monthly, at the end of 5 years, he will be having 163,000 pesos in his savings account. Now, one more example, Benjamin pays 9,000 at the end of each quarter in a bank promising 10% interest rate compounded quarterly. Find the future value of the investment after 10 years. So our given is our 9,000, the regular payment, 10% interest rate, 0.10, convert to decimal, compounded quarterly. So M is equal to 4 quarterly. So at the end of each quarter, so making this a simple annuity. And at the end of each quarter, the keyword is at the end of each quarter, so making this an ordinary annuity. Find the future value after 10 years, which is our time. So again, let's find our J, I divided by M. 0.10 divided by 4, that will give us 0.025. Now for our N, T times M, which is 10 times 4. So we will have 40 payments in all. So let us solve this now using our formula. By substitution, we will have F is equal to 9,000 because R is 9,000. 1 plus J, 1 plus 0.025, our J is 0.025, raised to N, raised to 40, because our N is 40, minus 1, all over 0.025, which is also our J. Now add these two numbers, 1 plus 0.025, and you will have 1.025. Now let us evaluate that using our calculator. 1.025 raised to 40, and we should be having 2.6850. So round up, it will become 2.6851 because the nearest decimal is 0 minus 1. So subtract minus 1 and you will be having 1.6851 divided by 0.025. You will, you will have 67.404. Then finally multiply these two numbers and you will be having 636 pesos. So this will be your output fee. Now there is a slight adjustment here. You will notice these are all now converted to at the end of each month, at the end of each month, at the end of each quarter. So these are all ordinary annuities. So please solve them using the steps provided in this video. And please tell your classmates about the changes on the frequency of payment. Okay. Thank you very much, guys, and be safe always.